Imagine an almost sheer cliff, where there's no path, no ledge wider than a human palm. Now imagine an animal calmly walking across it, as if the ground beneath its feet were flat. Footage like this isn't only captured in the mountains. The same thing happens on the concrete walls of dams, on old stone structures, and on other nearly vertical surfaces in different parts of the world. And every time, it's the same survival specialists: mountain goats. They show up there so regularly that this is no longer a matter of isolated cases or a rare anomaly, but a recurring phenomenon. But then two questions arise at once. How are they even able to hold on where equipment wouldn't help a human at all? And why do they keep climbing, again and again, to places where there seems to be no food, no water, and no obvious reason to risk their lives? Similar scenes are observed in many different parts of the planet. In the Alps, in the Himalayas, in the Caucasus, in the Rocky Mountains of North America, and in the mountains of Ethiopia. And this isn't about one particular animal that's spread around the world. In each region, its own specialists in moving across nearly sheer surfaces emerged independently. When people say mountain goat, it usually creates the impression that there's one particular species of animal that knows how to walk on rocks. In reality, things are far more complicated. Behind this name is an entire group of related species that live in different parts of the world and adapted to life among the rocks independently of one another. Moreover, some of them aren't even true goats in the usual sense. For example, the North American mountain goat turns out, by origin, to be closer to chamois than to most animals we typically call mountain goats. But in appearance and way of life, they arrived at almost the same solution. It turns out that nature has faced the same problem many times: how to survive where survival seems almost impossible. And each time, the answer turned out to be remarkably similar. But even this only explains who climbs vertical surfaces. The main question still remains open: why do they climb there at all? At first glance, it seems like there can't be anything valuable on a sheer cliff. No grass, no shelter, no water. But for many mountain herbivores, there's a resource there that sometimes turns out to be more important than food. We're talking about salt and other minerals. In high mountain regions, plants often contain very little sodium. In summer, when animals are actively feeding on fresh greenery and moving a lot, this deficiency becomes especially noticeable. That's exactly why animals start searching for any source of minerals, even if it means climbing to places where a single mistake means falling dozens of meters. In some places, they lick natural salt deposits right off the rocks. In others, they use sections of rock enriched with minerals. But the most important thing is that this principle doesn't only apply in the wild. If minerals appear on the concrete wall of a dam, animals will climb the dam. If minerals build up on stone masonry or another vertical surface, animals will use that too. The answer lies in the animal's own anatomy. If you look closely at the hoof of a mountain species, it becomes clear that it doesn't look anything like how most people imagine a hoof. Around the outer edge is a hard, horny rim. It's this rim that grips even the tiniest irregularities in the rock and works almost like a rigid clamp. But in the center is a soft, springy pad that can flex slightly under pressure. When the animal places its foot on a surface, the hoof doesn't just touch the rock. It increases the area of contact and literally molds itself to the shape of the outcrop. At the same time, the two halves of the hoof. Weight distribution also plays an important role. Mountain species have a very powerful shoulder girdle, and their center of gravity is shifted forward. Thanks to this, the animal constantly maintains stability on several independent points of support at once. The joints of the limbs also work differently than one might expect. They allow the hooves to be placed at angles that would be awkward or even impossible for most other hoofed animals. This makes it possible to use even the smallest footholds. This system is rounded out by a well-developed vestibular apparatus. The inner ear in these animals is relatively large and helps them continuously track the position of their body in space, even when the surface underfoot is nearly vertical. And finally, eyesight plays an important role. The placement of the eyes allows the animal to simultaneously monitor the surrounding space, the position of nearby animals, and the surface directly beneath its hooves. All of this together turns a sheer cliff from an impassable obstacle into an ordinary habitat. But even after fully understanding the structure of their bodies, it's hard to shake off another question. How does an animal even learn to use this system so well that it can walk on sheer surfaces almost from birth? The answer begins at the moment of birth. In the high mountains, you can often see a scene that looks almost unbelievable to a human. A narrow rock ledge, a cold morning, a sheer wall underfoot, and standing next to the female is a kid born only a few hours earlier. It has no experience yet. It has never seen rocks before and couldn't have learned anything from adults. But within the first hours of life, it's already able to move confidently across complex terrain, keeping its balance in places where a human would need a safety harness. Of course, young animals make mistakes and gradually refine their skills. But the very ability to move across nearly vertical surfaces is built into them from birth. It's not a special trick and not the result of long training. The same goes for jumping. Adult animals are able to leap upward more than 1.5 meters without a running start, using tiny footholds as points of support. For them, this is just as natural a form of movement as walking is for a human. That's exactly why what looks to a human like constant risk appears completely different to these animals, because the main danger in their world isn't up above at all. For a human, height almost always means danger. The farther it is to the ground, the higher the risk. But for mountain-hoofed animals, this logic works in reverse. The most dangerous place for them is down below. It's on relatively flat ground that their main enemies hunt. Wolves, lynxes, large cats, and other predators have enough speed, strength, and endurance to hunt successfully, but only as long as the terrain remains manageable for movement. But the steeper the slope becomes, the faster the advantage shifts to the prey. What becomes an obstacle for the predator becomes protection for the mountain animals. Sometimes the chase ends literally just a few meters from the edge. The animal takes a tiny foothold on the sheer wall and stops. The predator sees its prey. The distance between them might be just a few steps. But it can no longer take those steps. Any mistake on a surface like that would cost it its life. And then the danger suddenly switches direction. Now it's not the prey at risk, but the hunter. That's exactly why sheer cliffs, narrow ledges, and nearly vertical surfaces aren't an extreme environment for these animals, but one of the most reliable refuges that exist anywhere in nature. Vertical surfaces give them several advantages at once. In some places, they find minerals. In others, they escape predators. And most often, they use them for both purposes at the same time. And animals in very different parts of the planet arrived at this same solution independently of one another. And some of them have taken the art of living on the vertical to its absolute limit. In the mountains of Ethiopia live Walia ibex, one of the rarest mountain-hoofed animals on the planet. Not long ago, there were so few of them left that biologists feared the species would disappear entirely. Today, thanks to conservation programs, their numbers have gradually recovered and now stand at several hundred animals. Thousands of kilometers to the east, in the mountains of Central Asia, live baral, also known as blue sheep. They are one of the main prey species of the snow leopard. During a hunt, both species often end up on nearly sheer slopes. Observers have repeatedly documented scenes where predator and prey were only a few meters apart, separated not by distance, but by the ability to hold on to the rock. In Europe, chamois and other mountain species used the same routes for many generations. Over hundreds of years, their movements among the rocks have worn visible trails, which new generations of animals continue to use. But perhaps one of the most remarkable specialists remains the markhor, or screw-horned goat, found in the mountains of Pakistan and Afghanistan. Sometimes, trying to reach leaves, markhors climb not only rocks, but also leaning trees. And then an animal that just a few minutes earlier looked like a perfect climber suddenly starts to resemble a very stubborn gardener, determined to reach the most unreachable branches. And although mountain-hoofed animals have become the most famous specialists in living on vertical surfaces, they're far from the only animals that have chosen this way of life. In South America, viscachas live on rocky slopes. From a distance, you might mistake them for large rabbits, but they spend most of their lives among the rocks and are able to move across very steep surfaces with remarkable precision. In Africa, hyraxes solved a similar problem. These small animals make use of a special structure in their feet. Their pads are able to stay moist, which noticeably increases their grip on the surface. And here, nature has another surprising fact in store. The closest living relatives of hyraxes aren't rodents or hoofed animals at all, but elephants and manatees. But while sheer surfaces have always been a natural part of the environment for hyraxes, mountain-hoofed animals have, over the past few decades, increasingly started using structures that appeared on the planet only quite recently. It turned out that concrete dams, the stone supports of bridges, and even some old buildings can serve the same function as the natural rock faces these animals had been using for millions of years. The reason has to do with minerals. As water passes through concrete and stone, it gradually leaches out soluble substances and carries them to the surface. For humans, these changes go almost completely unnoticed. For animals constantly dealing with a shortage of certain elements, this can turn into a source worth the risk. That's exactly why mountain-hoofed animals are increasingly spotted on the walls of dams. From the animal's point of view, the difference between a natural salt lick and the concrete structure isn't as big as it might seem to a human. A similar situation arises near old stone structures as well. If a surface contains the minerals they need, animals will use it, regardless of whether it was formed by geological processes or built by people. Even ordinary mountain roads sometimes become places of attraction. After winter, traces of road salt remain on the asphalt, and animals may come down to the roadside specifically to make up for a mineral shortage. It turns out that humans, without even realizing it, have started creating new versions of the vertical and horizontal salt licks that these animals have been searching for throughout their entire evolutionary history. But there's another reason why footage of animals on sheer surfaces has started appearing so often in our time. And it has nothing to do with rocks, concrete, or even the animal's own behavior. Many people see this kind of footage as something new. In reality, animals have been using sheer surfaces for thousands of years. What changed wasn't their behavior. What changed was the number of animals themselves. For example, by the early 19th century, alpine ibex were on the verge of extinction. Because of centuries of hunting, only a small group of animals survived in the wild in a single region of Europe. Their total population had dropped to fewer than 100 individuals. Nearly the entire modern population descended from these few survivors. After protective measures and restoration programs were introduced, the species numbers gradually grew, and today stand at around 30,000 animals. This means that many of the scenes that now regularly show up in videos simply couldn't have been observed very often a few centuries ago. There weren't enough of the animals themselves. But this kind of recovery has a flip side as well. When an entire species goes through a period in which only a small number of individuals survive, genetic diversity inevitably declines. Because of this, the risk of inbreeding and the spread of hereditary problems increases. In some populations, specialists have already had to deal with disease outbreaks and take measures to protect the animal's health. And so, a paradoxical situation arises. At the very moment when people finally manage to bring these animals back to the cliffs, new threats appeared that can no longer be seen with the naked eye. But genetic problems turned out not to be the only challenge these animals face today. Over the past few decades, the very environment they had been adapting to for hundreds of thousands of years has begun to change. More and more observations show that in some regions, mountain hoofed animals are becoming more active after dark. The reason is simple. Air temperatures are rising, and daytime activity requires more and more energy. As a result, animals are starting to shift their feeding and movement to the evening, nighttime, and early morning hours. And this process is happening so quickly that researchers are observing it within the lifetime of a single generation. Another paradox arises here. For most of their evolutionary history, the main danger to these animals came from predators. But today, in many places, heat is starting to have just as much influence on their behavior as hunting does. And while the animals themselves adapt to these new conditions, humans are trying to understand how they manage to do something that still seems almost impossible, even for modern technology. That's exactly why engineers and robotics developers have spent years closely studying the anatomy and movement of animals that have learned to turn an almost sheer surface into an ordinary road. The creators of robots designed for work in the mountains, disaster zones, and other difficult conditions have long since arrived at the same conclusion. Before inventing your own solutions, it's worth looking at the ones nature has been perfecting for millions of years. Researchers are interested not only in the structure of the hooves or the ability to maintain balance. It's equally important to understand how these animals manage to continuously assess the surface, redistribute their weight, and stay stable in places where a mistake would seem inevitable. And although modern machines are already able to handle difficult terrain, they're still nowhere close to the abilities of animals that spend their entire lives on sheer surfaces. That's probably exactly why footage of mountain-hoofed animals continues to make such a strong impression. Not because the animals are performing some kind of special trick. It's simply that, for humans, a nearly vertical surface has always been a symbol of danger, obstacle, and risk. For these animals, that same surface means safety, food, and a chance to survive. And it doesn't matter what's in front of them. An ancient cliff, the concrete wall of a dam, or an old stone structure. For these animals, the vertical was never an obstacle. It was always home.